Hello everyone, you're welcome to today's class, the first day of our Python for data analysis class. You're all welcome. Welcome, Mr. Charles, Miss Madam Glory. You're welcome. You're welcome. Nice having you guys. So for today, we'll be starting with the introductory aspects of the Python for data analysis class. Very, very important that we review what we know and also add to what we've known before we proceed. All right, so that's why the first day and second day has been dedicated for what we. All right, class while we prep for the more additional concepts. All right, so can you all hear me? All right.
Yes, we can. I can hear you. Actually, I can.
Okay. So we'll be looking at some concepts for today. Some concepts. I believe we've all gone through our curriculum and we know what we have for today. For today, we have to understand or remind ourselves on who is a data analyst, and also what are the necessary tools and as a data analyst work with. And secondly, who does a data analyst work with, and also what does a data analyst do? And we now move forward to the difference between data analyst, data engineer, and a data scientist. So these concepts are very, very important. You must know this concept. So our next is what is data science? The overview of the key concepts and applications. All right. And we'll now move forward to the data science workflow. The point 6 and point 7 is kind of similar, but we'll discuss on that. All right, so what is the data analyst? Glory, can you just remind us what is data analyst? Or who is a data analyst? Pardon?
A data analyst is someone who transforms data. Data can be in form of numbers, text, features, and everything. Who transforms raw data into something meaningful that can make decisions, that can help an end use of that data to make a decision. In short, it transforms like raw materials into a finished product. Yeah, they will understand.
All right. And can you explain that to me as if I'm a 5-year-old? What we do here? Can you illustrate using more like a 5-year-old example for that definition?
Someone who turns something that is raw material into a finished product. Like, you want me to give an example?
Yeah, raw material, how? This is my first time hearing who is a data analyst. My first time of hearing data analyst, I think so. This is my first time. So I wanted to explain it to my own understanding.
Okay, I don't have the account explanation, but I can explain it in a layman's language. For example, an example I can give, like, for example, elections. During elections, people go to vote, but at the end of the day, results are needed. How do you get those results? It's compiling of that data. Data here means the votes from the citizens, compiling them to see who is the winner, who got the highest in several locations or several states. for me, that's an example I can give for now. Something else, like maybe students have done exams, a teacher collects that data, analyzes who is the best, which subject improved here, who is the most performed student. I think that's now like for a 5-year-old, everyone has gone to school, everyone can understand that example of a class.
Yes, you're on point. Papa Charles, can you say anything on that? Do you have anything to say on that?
Okay.
It's more like a data.
It's more like what? Okay, so hello?
Information on what is going on. Like what you said, student that wrote exam, the teacher called someone to analyze, to check who scored highest, who did best, and what area that can be improved on. That's good. That's what data analyst is. It's more like a data detective. You want to discover what is going on in your data. All right, so let's proceed. What are the necessary tools a data analyst work with? What are those tools? I believe we've learned, if I'm not mistaken, 3 tools: the Microsoft Excel or Google Sheets. Can you use Google Sheets very well? Glory? But Charles,
Yeah.
any of you can use Google Sheets very well? Can you use it?
Yeah, I would say that to an appreciable level, I can use it but my primary spreadsheet tool is Excel spreadsheet. So
Okay.
yeah,
How
my
about you,
primary,
Glory?
Pardon, I've
How
not
about you?
heard Charles' answer.
I said, can you use Google Sheet very well? How good are you with Google Sheets?
Google Sheet.
Yes, how good are you with
Not perfectly. I can't say I'm conversant with it 100%. I'm more conversant with Excel.
Yeah, that means you're kind of I won't say you're handicapped, I won't say you're limited because because what if now you
Pardon?
face I won't say you are limited or handicapped. No. What if now you are facing a scenario whereby you are given the data with your system and you have internet at your disposal? How can you analyze that data? So as a data
I'm not
analyst,
like, oh sorry,
yes, go on,
not
I'm
like I
with you.
am at zero,
Yes.
because even Excel has the online thing. Not like I am zero. I interacted with Google Sheet, but I preferred Excel because I'm more conversant with the formulas. There are times I find I can't remember a formula in Google Sheet. But of course, if you're faced with a client, of course you work with this. There's a time I got something like that to work with. You just research on it. Everything now it's on YouTube, and you are good to go. As long as you have an idea of it, you can always navigate your way. So not like I am at 0-0.
That's good. Thumbs up to that. Being a 0-0 is not good at all. All right. We have Excel, we have a Google spreadsheet, and then that's for spreadsheets. Is there another spreadsheet thing we have? Just those two, right? Another one again for data analysis. Guys, any other spreadsheet again, apart from Excel and Google Sheets? I don't think there's any other one. Is there any?
I don't. I think I keep forgetting the name. I think it's fairly new. They said it's AI, whatever. But I keep forgetting the name anyway.
Okay, spreadsheet though.
It's
Ah,
a spreadsheet. Yeah, yeah.
okay.
It's a spreadsheet.
All right. So assignment 1 now, we need to make research on that particular. If there's another spreadsheet, we know we can as well make a little research on that. All right. Let's take note to make research on it. Any other spreadsheet that we think there is. All right. Someone just joined us. Corey, Moses, Chubidike. Hello. Good evening.
Good evening.
Is it for this class? Is it for this class? Corey Moses Chukudike. Hello?
Your
Hi,
claim
good
is kind
evening,
of
sir.
cracking. I don't know.
All right. Now we have the
My
data
network. Good evening.
visualization software. All right. All right. Okay. Mr. Corey, good evening. You're welcome. Is this your class? Is this your class? Sorry, excuse me. Is this your class?
No,
Is this your class? Sorry, excuse me. Your class?
no,
This Python class. Oh. Are you sure?
yes. I just came to participate as a visitor.
Ah, okay. Oh. All right now. So we have visualization softwares like the Tableau, Power BI. These are the two most most commonly used tools for an Excel, yes, for visualization. Can we use Tableau? No, we didn't teach it here now in Poshem. Tableau. So if you are pursuing to learn Tableau elsewhere online on your own, please do well to and learn it too, because for instance, if someone want a carpenter, one person have hammer, one person have chisel, the other person just have hammer. Who do you think the carpenter will employ? The man will employ. Who will get the job? Is it the one with chisel and hammer, or just the one with hammer? The guys,
The one with chisel and hammer.
hello?
The
Can we
one
all
with
hear me?
Yes, I can
The
hear
one
you
that
now.
okay, the one that have chisel and hammer, right?
Yes.
That's important of being conversant of more than one tool or skill. All right. So what are the tools a data analyst work with? Programming softwares. Programming softwares such as we have Python and R. Most persons say we say that don't need Python for data analysis. No, Python is also needed because some organizations prefer you using Python. Python and R. I don't know if anybody uses R again now, but Python is most commonly used. Everybody. Mark Zuckerberg was having an interview some time ago. They were asking him if he's to build Facebook again, what language will he use? He said Python. He said he will use Python for everything. Why? Because Python is not the will I say the most used programming language now. The most used programming language. Is my voice broken? Hello? Are you guys hearing me? Is my voice breaking?
Yes, at some point you were actually.
But now, how about now? Can you hear me now?
From my own end, it's better now. From my own end, it's better. I don't know about other persons.
Or I shared my network.
I don't know. Probably it's mine. The network has been terrible this week.
Okay. So R and Python are the programming tools being used by data analysts. Then database is also we have the MySQL, we have the Progress, and we have the Microsoft SQL Server. These are tools used by data analysts. We also have the statistical tool, the SAS and SPSS for advanced statistical analysis. Someone was asking me a question so I think that was last week, if Python is a statistical tool or a programming language. I told him that Python is a programming language, but it can perform statistical analysis with it. is a programming language, but it can also perform statistical analysis. So these are tools, various tools that are necessary tools for data analysis work with. All right. Who does a data analyst work with? So help us with that, Papa Charles. And
Who
Glory
does it?
also. Yeah, who does a data analyst work with?
I think a data analyst ideally will work with the data engineer.
Okay.
Work with in a team of data engineer and maybe a chief operating officer, depending on how big the team is, and maybe a project manager or program manager. And if it's a business-oriented team, they might have a data analyst and somebody who is focused on business analysis differently and all that. So I think basically that's the people a data analyst would work with.
All right. How about Madam Glory? Any inputs?
I would just stand. You also need an administrator for the database. You also need a data entry specialist, because where will you get the data from? Okay, generally, I guess you work with everything because data is everywhere. You work with everybody in the organization. That's my take.
All right. But if I may
Because
ask,
everything now, data is everywhere, right?
yes, it's everywhere. It's everywhere. It's everywhere. A lot of data is everywhere. A lot of data is everywhere. A lot of them. Now, if I may ask, now, a data analyst should have a skill as regards to SQL so as to query data. All right. Now, do you think we also need a database administrator in our midst again as a team member? Do you think if the data analyst has been, can you hear me?
Yes.
I said a data analyst should have the skill of querying data, which is having SQL keys, a skill, knowing how to work with your PostgreSQL, your MySQL, and Microsoft this thing, server. So, do you think we also need a database administrator as it?
I think you actually still do. I think it boils down to
I can't get the last sentence.
Do you think we also need a database administrator as a team member? But Charles, go on. Okay, go on. Anyone can answer, please. But Charles or Glory.
Glory, go
You
ahead.
asked if you need the data administrator, right?
Yes, we have said it now that one of the tools needed by data analysts is the database tool. That's knowing how to operate your SQL, Microsoft Server, MySQL, and PostgreSQL. Yeah. Do you think we still need a DBA in our midst? Database administrator in our midst as a team member? Yes. Okay, explain.
Because for a DBA, I guess you'll be you'll be a specialist in that area, whereas I will not be. Okay, yes, I will know the SQL, but not to that extent. So for me, I think I will need for that question. I think he or she should be part of the team. I don't know about Charles.
All right, Charles, help us with that.
I think there should be a DBA because it also boils down to their responsibility, a big job description. You get, and I think for a data analyst who is skilled with SQL, your responsibility is mostly querying data and trying to carry out certain statistical analysis with data, maybe depending on where you're working with. If it's a company, a hospital, maybe you're looking at bed ratio. If it's a business, you're looking at revenue ratio or this thing, what's it called, the profits, average profit and all that, or the profit ratio. So I think the responsibility of a database administrator from maybe my little research that I've done is quite different because the data analyst would have to, at to a point, depend on the database administrator to, so to say, manage the database of the company, especially for a firm that has a bulky database. So you will need a database administrator who is skilled in that area, not just about querying data. Okay, so I think you will need a database administrator because the skills or the technical skills needed for a database administrator is quite different from the technical skills needed for what's it called, a data analyst. So that's just my take on it. You need that.
Okay, yes, yes. Yeah, a data administrator is needed because crucial, because they play a very crucial when it comes to, when it talks about the data on data storage. Those guys are, they are
Excuse
needed.
me.
Go on.
I've realized you are not recording the section.
It's recorded.
Okay.
Yeah, it's recorded.
Okay. No problem. Thank you. Thank you. Thank you. Sorry.
All right. Their role is very, very important, very, very crucial. They play a very crucial role when it talks about the data management. That's to say data storage, data access, tell you about data quality and the integrity of the data. We need a database administrator. Even talking about data security and data compliance, they are very, very needed in the team. All right, that's a very, very important point to note. All right, and we also need other data analysts because one analyst cannot really give you it's not really the best. You can get several analysts with different insights and different ideas to contribute. All right. What does a data analyst do? What do they do? You are a data analyst now, you and Papa Charles. So what do they do? What does a data analyst do?
A data analyst basically analyzes data available so as to draw insights and be able to make data-driven decisions. So I think that's just the basic part of it. A data analyst is someone whose responsibility revolves around analyzing the data of a company or a firm or organization he or she works with, so that the company
Okay.
can make
So if I
decisions so that the company can make decisions that are data driven, that are not just based on guts, but decisions that are backed by facts and available data.
okay. How about Madam Glory? Can you help us with that? Any contribution?
I think I would just add on. They also do the reporting because it doesn't end at just the analysis. You also have to do the reporting and, yeah, as he is saying, giving the insight to the directors or the stakeholders of that data. And also it can involve cleaning, yeah, cleaning of the data, transforming the data, and then now analysis, and then reporting.
Okay. So if I don't see data, how will I clean the data? How will I analyze the data? How will I report the data? Eh?
I'm assuming there's someone who is doing the, okay. I think data analysis also has the hierarchy. Just like previously you have asked the question of DBA. For me, I have also thought about it. It's just like the way every professional has hierarchy. For example, accountant, you find there's a junior accountant, there's an assistant one, assistant two, senior, and the chief accountant, like that. So even in data analysis, there's also that hierarchy. There are people who are doing the data collection or data entry. For if you are doing that as in research or something like that. But if it's an organization, of course, you're getting it from the system. I will assume, for example, if you are working in a store, already the data is being collected maybe from the cashier side or from the stock and such. So it starts as the data collection if you have no data, depending on where you are
Exactly.
working and the
Yeah.
department we are talking about.
Okay. If you are being called upon as data analyst now, that we are having this problem, data analysts, they are problem solvers. I get you guys. They are problem solvers. We're not just here to analyze the data and give a report. No, they are problem solver. So the first task there, the first thing they do there, they collect data. They collect data, even though they have a process of data collection. They are the ones, they will tell you that, okay, you want me to solve this problem for you. Please, I need this. I need to look at the data that will be needed here. What if now they gave you the task, take, you have to do the collection, you will clean, you will analyze, you will visualize, and you will what? You will report. Basically, that's what they do. Because if you don't have any data, you won't clean. You don't have any data, you won't analyze, you won't visualize, you won't even do any reporting. Basically, data analysts, they do collect data, clean data, analyze data, visualize data, then they report data. All right. So that we are clear on that now. All right. So what is the difference between a data analyst, a data engineer, and a data scientist? This is where we need to separate Paul from Barnabas. There are some job roles. Like they will say they need a data analyst who can do this, who know AWS, who know pipelining, who can be model. I said just a data analyst. I said, wow, these guys are giving a 3 persons role to 1 person. Well, now who is a data analyst, a data engineer, and what are the differences? Guys,
Okay, let me give it a shot.
give it a shot, the big shots, the big shots.
Okay. A data analyst is a professional who is involved in the collection and analysis of data so that businesses can make data-driven decisions and gain insights. While a data engineer, so to say,
Yes,
that is a data professional that is responsible for building models that helps in the collection, storage, and organization of this data for probably easy access for the data analyst and other data professionals.
Okay. So data engineer build models too.
Yes, that's my this opinion on that, that they are data professionals whose primary responsibility revolves around building, what's it called? Building models that help organize and store data for easy access for other professionals.
All right. All right. Okay, that's a model is like an architecture now or structure. Is it what you mean?
Yeah, okay. I think
Okay.
that should be the right language that helps build architecture or structure. Yeah. Then the data scientists. How do I describe a data scientist?
Okay.
Hmm. The data scientist is a data professional whose responsibility, I don't know, I'm kind of stuck there.
All right, call for help now, Madam Glory. I
Auntie
believe
Glory,
you can help him on that.
help.
He's calling you for help,
No,
help,
me,
help, help.
I don't have a distinct about that. I don't know. I'm not sure about that question.
Okay,
I know an
okay,
analyst,
okay.
but I'm not sure about the engineer and the scientist.
Wow, wow. Who will not help us now? Who is here to help us? Who is on the call? All right, okay. A data scientist. Is now I will say, yes, I am a data scientist. What we do, we use we employ statistical techniques and machine learning techniques and algorithms to analyze and make predictions. I get in. We employ advanced techniques, statistical techniques. Then use machine learning models for predictions, classifications, and detection. We build models basically for that. So if data analysts, if their own role or their job is to analyze data to give you insight that helps making decision, a data engineer helps you to organize the data and create a system or architecture where a data can easily be accessed. So a data analyst also work with data engineer too, and data scientists. They all work together because they all have different roles. The data scientists use that insight insights gotten by the data analysis being used for is being used to make predictions using machine learning models and other statistical techniques. All right. So if they ask you what's the difference between these three on a layman terms, can we try and give us a layman definition on these three roles? Data analyst, a data engineer, and a data scientist. Can we try?
Pardon?
Can we try it? Can we break that definition down? The three different roles. Can we break it down and give us a very unique definition as a layman? Example now, I want to I have balls. I have a set of balls. Can you use that balls to explain the data analyst role, data engineer roles, and data scientist role? Can you? Balls or toys? Can we?
I've not gotten your definition of a data engineer. Scientists have heard you say they use statistical and machine language to forecast, but I've not heard the
Yeah.
engineering.
Okay. Papa Charles told us that data engineer, what they do is that they design and they build architectures or system that's that helps in storage and to process data. It can be easily accessed by the data analysts. That's what data engineer does, right? Papa Charles, that's what he said now, right?
Yes, sir.
Papa Charles. All right, that's what you said now. Okay.
Yes, sir.
So now let's break down this concept into let's play with this concept. Break it down into a 5-year-old. Want to tell a 5-year-old what data analyst, what does he do? Data engineer, data science. What are the difference? Just use an illustration for that. You can use a toy or a balls or data analyst. They count the number of balls. For example, now we have some balls together. The data analyst, what did they do there? What does engineer do there? And what the scientists do? Can we try?
Okay. Let me give it a shot. Now, let's say you have a ball or maybe a set of toys, Lego toys.
Okay.
Now, the responsibility of the data engineer in this scenario would be to organize or put a system in place, a structure in place that organizes these toys, this, so to say, Lego toys, in a way that the data analyst can easily make sense of it. Maybe if it's a Lego toy with different colors, the data engineer can decide to put the red colors in one bag, the green colors in another bag, the yellow colors in another bag, maybe the purple colors in another bag. Just that way can be the responsibility of the data, what's it called, engineer, when it comes to Lego toys. Then the data analysts in this scenario, what his responsibility would be with those toys is, you want to create, maybe you want to use the Lego toy to build a toy soldier. You get, to build a toy soldier. The responsibility of the data analyst in this scenario would be to identify which from which bag do I get the necessary, so to say, toy sets to build this toy soldier and all that. And for me, I think the data scientist does what the data engineer does at a larger scale, maybe using programming language, in-depth programming language like Python and all that. On a larger scale, maybe he wants to, the data scientist in this regards might be the person who is not just building a toy soldier, but has to find a way of building thousands or a platoon, or in this scenario, let me just say maybe a platoon of soldier, not just a toy soldier in this case. That's just my thought on the matter.
Okay, you said a lot. You tried. You've done well. How about Glory? I believe you heard what Charlie said. Now you can say something now.
On that one, honestly, I just go with what he said.
Okay, not really digested it now.
Pardon?
You haven't digested it now. You are still assimilating, trying to process it, right? You are still processing what he said now.
I guess I'm losing it at the engineering. Then I never had the example well.
Okay, the engineer is all about is kind of arrangement or arranging your data in such a way that placing the system in place, keeping the system in place in such a way that your data can be easily accessed. Talks about accessibility. I get storage, kind of storage and accessibility. That's what they do. They maintain a system. Let's just say, like what he said now, we have the Lego toys. They are scattered. When they are scattered in such a way, you can't really use them. So what engineer does, they arrange those data, they keep them in place. I keep this ones now will be here. When these particular colors will be here, this size will be here, this size will be here. So when you want to use them, you now use them properly. You now pick them. You say this particular number of quantity of red will be used for this Lego soldier. These ones like that. Just that is what a data engineer does. They kind of provide a system of arrangements where your data is arranged. Example, like maybe the pipeline. Maybe the pipeline. Example from a particular data a storehouse to your particular to your working environment. That's what they do. All right. Are you clear now? Are you clear?
Yeah, thank you.
All right.
Yeah.
Then bringing relating the data scientist role now in this toy, this Lego toy that you just said now. Now, what can we say about that? Is that a data scientist, for example, now, okay, the first time the data analyst was able to count the number of Lego toy that we use for beating of the soldier, right, Mr. Charles? And eventually they built the first one. So data scientists now will now take note of what was used for the building, and it will take note of that one, the first soldier, the second soldier. Then you will now predict, okay, since this was used here, that means to say in so time we'll be able to use this particular number of toys or colors to build this particular soldier. Are you getting me now?
Yeah.
Is it clear? Is it clear? Hello?
Yes, we're with you. Yes.
All right, so we move.
Sure.
Now, okay, what is a data science? What is data science? Now we've known who is the data scientist. The one that uses who build models. All right, the one who build models, who use employ advanced statistical techniques, make predictions. All right, now what is the data science? What is data science itself? What is it? Anyone? Anyone?
I think it's like the way we defined the data science is when you send I think data science now will be the act of making forecast and prediction using machine learning and probably programming and the rest to forecast.
Nice one, nice one. You tried very well. You tried. How about you, Charles?
Yeah, about data science, I think it's a field that combines machine learning to help gain further insights into data as well as to get better insight from the available data. Basically, that's just my thought on the matter.
Yeah, we've said it all, kind of. We have he said he's here to observe. Okori, can you help us out here? I don't really know him, but he said he's here to observe. Corey Moses, please help us out here. What is data science? Hello, Corey Moses.
Okay.
Are you there?
Yes, I'm here. Data science could be a
Sorry,
course.
sorry. Sorry, excuse me. Which cohort are you, sir, please?
Okay, the past cohort, like the graduating cohort of cohort 1.
All right, you're welcome. Nice to have you. All right, go on. We can hear you, sir.
Okay. I say data science is a course or it's a course that deal with the application of analyzing data, creating models, and it has an advanced concept in data analyzing.
All right. That's data science for you. Okay. We can say the data science is an interdisciplinary field. Yes, field that combines data, computer science, statistics, mathematics. This is a major definition of a data science, is an interdisciplinary field. It combines computer sciences, statistics, mathematics, and domain knowledge. When it talks about knowledge of healthcare, finance, marketing, commerce, business, all the domain knowledge to extract meaningful insights, patterns, and also make predictions too. All right. So that's what what data science is all about. It's a field. It combines various fields together. Domain knowledge, computer science, mathematics, statistics. Is a core, like me, I see data analysis, visualization, and as a subset of data science. Data science comprises of data analysis. You also visualize data, domain knowledge, apply mathematics, applying computer programming, applying statistics, everything like at all that will be useful in solving a business problem. I see that as data science, because you can't call yourself a good data scientist if you don't know how to analyze data. You must know how to analyze data. You must also know how to visualize data because we get insights that will help us in predicting our predictive models, and also in making decisions too. A good data scientist must know how to visualize a data very, very well. Must have good mathematical knowledge and statistics too, and also computer programming. That is why you are here. You're on the right track, learning Python. All right. So any question on that before we proceed? Any question on that? All right, none. Okay. Now the overview of key concepts and applications. There are key concepts in data science. There are key concepts. One, data cleaning. Sorry, data collection, rather, before data cleaning. Data collection, like I said, that if there's no data, nothing can be done. You cannot clean, you can't visualize, you can't analyze, you can't even report if there's no data. One, data collection. Because a process of gathering must be in place. You must gather your data. It must be in place. Currently, there's a project that I started some weeks ago on healthcare that talks about predicting if a particular patient that was treated diabetes, if he will be readmitted. Is a problem that was faced in a particular hospital in the US space. So they're kind of penalizing hospitals that most of their patients were treated and they came back to the hospital. They were fined. So You are building a model to check if a particular patient after treatment, if you return to the hospital in the next 30 days or before 30 days or not. That's to check what are the major cause of that. Are you getting me now? So one, data collection. We're not trying to collect data, ask for relevant features. What do I really need for this model? What are the records needed? All the diagnosis 1, 2, 3 needed, and all the results as regards to diabetes. Because diabetes have various columns now. When we are taking a diabetes test, you have what we test for this. It has various columns. So all those features are needed. So data collection is very important. Even for analysts or scientists, you must collect the data. Secondly, data cleaning. This phase is very, very important for as a data scientist. Data cleaning for data analysts is different from data cleaning as data scientists. They are all cleaning, but for a data scientist, you don't clean anyhow. How? Because there are some in data cleaning, there are what we call data pre-processing. You pre-process some features due to some reasons. I get him now. You pre-process your features. Why cleaning those data? You pre-process them. For example, now in this particular program I'm solving, there's one ALC tests score. We had some missing values, about 9,000 missing values for that particular column. For a data analyst, you might want to that's if you are not wise to ask your stakeholder, you might want to drop that column. But when building your models, that column is very, 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 very important in building your models. That column really tells if that the glucose and the ALC test result really tells if that patient might likely come back or not. So in such case, we pre-process it. Is what we do. You just categorize those ones that are missing into a number. We use -99. It's not as if it's going out to it's still here. It means something. For example, now it means that these particular values, they are not available. Kind of, if it's some person, they drop that column, but no, that column cannot be dropped because that column is very important. We just have to hot code it, encode it, then move on with our analysis, then prediction, bit of our model. So data cleaning is very important in data science. Then we have the EDA. Under analysis, we call it EDA. That's explorative data analysis. We explore our data to get more insights. That's EDA. After EDA, you visualize normal. Visualize to check for trends. Check for relationship between various features, relationship, how they affect your statistical analysis. You check for correlation, check for hypothesis tests, and t-tests, how various features affect the other. So these are concepts before you now go to your machine learning modeling proper. So all these steps are very important. If you don't analyze the data well, if you don't clean well, you won't really have a good model. It's not about building. When I was learning data science, building machine learning models, I was just all about rushing to build the model sharp before you know model accuracy, check accuracy. No, that's not it. You have to understand some certain things. When analyzing your data, you understand relationship, those important features very well. You do the understanding in your analysis. That's why a data scientist must know how to analyze data, know how to perform a statistical analysis, perform your t-tests, your hypothesis tests to check if to check the null hypothesis if it's true or not between two different class samples, this feature and this feature. Is there an interaction? Because at times when two features are interacting, it helps in your model. All right, am I making sense? Then finally, we have our model deployment. Of course, your model will be deployed for the users to engage and make decisions with it. So that's basically the workflow, basically the overview of the key concepts. Now, applications, data science can be applied in the healthcare. I so much love healthcare. Do you know why? Can you ask me why? Ask me why. Can you ask me why? Why do I love healthcare? Papa Charles, can you ask me why? Can you ask me why? Why do I love healthcare? Not finance, not marketing, but healthcare. I don't study health. I'm not into the healthcare background. I did computer science major, but I love healthcare. Do you know why? Because it saves life. Healthcare talks about it's so practical. Saving life is very important. I'm using data science to save life. To save life. All right. Can you really explain kind of what aspect in healthcare that we think we can employ data science? At least I've said one, to know if a patient will be readmitted. Do you have any idea on that? That's called predictive analysis. So to predict if a patient will be readmitted or not.
Okay, I think another area they can use data analysis for healthcare is
data science.
Data science, I don't know. I don't know if data science also works. I think it should work in that area. Is bed ratio. How long their patients spend. I think bed ratio is basically how long a patient spends in the hospital. You understand the number of days divided by the number of beds and all that. I think it can maybe for big hospitals or big hospitals. Maybe if using Nigeria as a case study, you can look at the bed ratio for the what's it called, the teaching hospitals across Nigeria. Maybe I think that's where data science will come in. You're looking at from UPTH, UNTH, just the teaching hospital, maybe Lutz and all that. You're just looking at how long patients spend in the hospital. That's basically, I think it can help in that regard.
Okay. Glory, can you help us with that, please?
Pardon?
Can you help us with that? Healthcare. What are the areas in healthcare? What areas in healthcare that we can we apply data science?
In analyzing maybe diseases and maybe the number of people who have that disease, how oftenly people are getting it. For example, now cancer is a thing, so maybe trying to understand, to get the numbers. Also, it can also be used in what else? Healthcare. Also in maternity, birth rates and also death rates.
Is it for prediction or just analyze? Is it for prediction or just to analyze? Is it for prediction or just to analyze it?
Oh, that one is for analyze. Oh, we're asking about prediction.
Yes, as in
prediction,
data
I guess,
science,
in terms on data science, I think on prediction, I guess in terms of medicine.
I think
I don't
it
even.
actually can be used for prediction. You can predict what is it called? Maybe maternal mortality rates using data and all that. I think you can actually do that. You can make such prediction with to determine the
Yeah,
death rate and birth rate. You can.
that's a
But what
healthcare now.
of science can it? Okay, I also have an idea of drugs. For example, discovering a certain drug's cure or something like that, or that is science. I don't know.
Yeah, drugs
Like the way
discovery.
people were saying COVID was laboratory prepared. It's not like a disease, something like that.
Hmm.
I don't know. I have
You
an idea, but
you
I don't know how to
you
put it.
you is drug discovery you can use data science to analyze or discover a drug candidate, in the sense that everybody has different genes and different biological structure, and it's not every drug that works. Every drug has a rate at which they work in the individual body. So you can use data. It's data science using predictive models to understand and predict certain drugs for various patients. Are you getting me now? You can use it to predict certain drugs for various patients. That's one. That's for drugs discovery. Discover the particular drug that will be suitable for a particular patient. All right.
Okay.
Okay. So that's for that. Then we also have other areas in medicine, in healthcare. We have image. The one I love the most, I love imaging, medical imaging, where we use machine learning to build a image recognition system that will help them to detect abnormalities in X-rays, in most X-rays. Previously, last year, I read about what we call image segmentation. Image segmentation is a kind of computer vision technique whereby we segment image to understand the magnitude of that image, and we can apply that in medical imaging, whereby we can understand the size. Example, a tumor. When you do brain scan, there will be likely a sign. If someone have brain tumor, there will be a sign there that person have brain tumor. We can examine that image using a computer vision technique. That's this thing, image segmentation, to segment the size of that particular disease, and to predict how long have that disease been, how long has it been in the person's health, that ailment, and predict how much time does that particular patient have. That's image medical imaging. Is very, very important, very, very useful in that area. Medical imaging, I love that area so much. All right, so that's for healthcare. Secondly, in finance, can we help us? Can we try? What are the areas in finance that we can apply data science?
In modeling and predicting maybe the profits, future profits, expenses.
Yeah, you're on track. Go on. Are you done?
Budgeting.
Okay. Yes, very well. Budgeting. Yes, as our country is now, we have Nigeria, we have your country, Kenya, ahead. Due to the rate of let's say economic growth or not, you can use it to predict what will be likely budget for next year, right? Something like that. Yes, prediction of the budget. Yes, what will be allocated to those various sectors in the government. That's a very good one in finance. All right, predicting. Yes, predicting of budget and expenses. That this particular sector shouldn't spend so amount of more than this amount of money in a month or in a year. If they spend, now you have to now investigate. That's where the analysts come in. now investigate why did they spend such amount of money in this particular month in this sector. So, example now, we can also use it for fraud detection to identify fraudulent activities. Why at times some years ago when I was robbed, was I robbed? No, they stole from me, not robbed. Which I was not robbed, they stole from me. All right, that was some years ago where I lost my phone. Actually, they picked from my pocket. So they used that phone, they withdraw all my money, transferred everything. Before bank now discovered that withdrawal is not really from me, they now made a PND on that account. And that was after I've done the whole withdrawal, after they've done the whole withdrawals, that via I think it was they were withdrawing, they were buying card, withdrawing, buying airtime, withdrawing, so until they now finish the whole money. So now data science come in now, they help in fraud detection. It says that they'll monitor your transaction using machine learning models. They can identify when a particular transaction is fraudulent. They will study. They will now add features like your spending patterns or withdrawing patterns. Those features. So now, if a particular customer now exceed that limit in that day, or something's going on, they might place a PN in that account. If it's you now go to the bank and show that I'm the one who they should open the account. That's how machine learning helps now in fraud detection. All right. We also have a risk management. When in forex trading, machine learning models help you to manage risks. This particular trade, by forecasting, it will not really just place so percentage for this trade. Don't place all your capital. So all these are ways on areas we apply machine learning. All right. Another one again, we have marketing. Now, Papa Charles, can you just give us explain how we can apply data science in that your is it logistic, or are you in the logistics sector, or you are the transport sector? Young Shagru, right? Are you in the logistics sector or you are in the transport sector? Can you just explain how machine learning how data science can help in that regards? Papa Charles. Papa Charles, are you here?
Yes, I'm with you, sir.
All right, go on now. I was asking if you are in the logistics sector or you are in the transportation sector. Section, yes, section.
Yeah, we have a logistics arm, and we have a passenger transport arm also.
So which part are you? Okay, just explain all. Just explain how we can use data science in that regards for the passengers section and logistics section.
Okay, I think one area data science could help. One area that
Are you there? I don't think we can hear you. Can you hear him, please? Glory, can we hear him? Can you hear him, Glory?
No.
I think he's off. Can you say something on that regards, please? Have any idea? You have any idea?
Logistics.
So logistics, yes, and transport and passengers.
How we can use data science.
Exactly.
And maybe how to predict which I don't know if that is science or analysis. Like,
You know, analysts don't do predicting. So you know, they don't predict though. They don't build models. They just analyze and get insights. Look at what is happening. They can't tell the future, but we can tell the
okay,
future.
if I'm to use logistics, I don't have an example of an African setup, maybe an American setup, because for us, I guess logistics is simple. But I guess in an advanced economy, they can use it to predict like which vehicles suit which mode of transportation, like that. That is what I'm thinking. Which vehicles are more cost effective? Like now we are finding there are many the electric cars. That's my idea.
I think you are missing the concept with a data analyst and data science. I'm missing the concept.
Pardon?
You are missing the concept.
Maybe you can help me there.
Okay. For logistic, I get
Charles
it
is
now.
back. Maybe he can answer. Charles.
Okay, Charles is back. Charles, go on, please. Go on, please. Charles, are you back? Are you there?
Yes, I'm back, sir. I'm back, sir.
All right, go on. We were saying something. I think your network threw you off.
Yes, yes.
All right,
so I
go
think
on.
one of the area it can help is to help optimize delivery time. You get delivery time of, for instance, there are some destinations that tends to have more traffic than the other when it comes to logistics, as per people tends to buy more things from those areas than the
Thank
others.
you. Gloria, are you hearing what he said?
No.
Okay.
Repeat, please.
Okay. Go on.
Okay, Glory, what I'm saying is for the area of logistics, one area data science can help is to optimize delivery time. For instance, as from experience, there are areas in Nigeria that tend to have more goods supplied to than others.
Even in Kenya itself, not even Nigeria. Even in Kenya too, not only Nigeria. Kenya, you guys have traffic at times now.
Yeah.
Go on. Don't say like only Nigeria. Kenya too, they have traffic. All right, go on.
For instance, let's say commercial cities like Onitsha, Aba tends to have more goods going to that destination than maybe other areas when you compare it to, yes, when you compare it to a city like Port Harcourt, it tends to have more traffic of goods going to such areas and all that.
Okay. So how will data science not help you now?
I think how data science is going to help is going to help you determine how many vehicles are you going to allocate for moving goods to this location, and how many what's it called vehicle are you to allocate to this location, basically.
Because of the traffic, right?
Yes.
Okay.
Not just because of the traffic, so to say, because of the volume of goods available to each destination. Yes.
Okay. Now we are trying to optimize traffic or routes, delivery time, right? Let's also optimize routes also. You know, it can also help us on how to know the particular routes to follow, because per time routes could be congested due to per time. Example, now you can't compare routes at night in some areas and some in daytime, or in the morning. If you're a logistic company, now we say okay, in the morning so region is kind of you can kind of free, leave it out with fast. But if you go by afternoon or evening traffic, so it's used to optimize the routes. Okay, this particular goods, but also time past this route. Data science is used for that. All right. And it's also used previously, some months ago, we did a kind of project for called it's called fleet optimization. They try to optimize how the certain company in South Africa, they want us to analyze their vehicles, their truck that conveys wood from the forest to um, their industry where they produce both the furniture with those woods. So now they're trying to optimize their fleet system, know the vehicles that consume more fuel, and know the reason, and know what the cost of that fuel consumption is. It they stop a lot, or the vehicle is not good, or is faulty. There also be the predictive model that helps us to predict a particular liters of based on that analysis. Be the model that will predict how many liters of fuel that will be used, or diesel that will be used by a particular fleet system. So that's in that regards to data science also helps you in that regards. All right, that's the predictive maintenance of fleet optimization. All right, we have other ones. We have in marketing also. Marketing, we have customer segmentation to understand the various groups, various customers based on groups of interest. It can help see in future predicting. That's to say that if I done customer segmentation, I know that the particular groups of customers, they like the particular goods or products. Last year I built a model on for electronic store that helps to recommend various products to users. That's still marketing. Build predictive models to recommender system that suggest product or services to their customers based on their previous interaction. Even in social media too, we also use data science too. I believe we experienced it now, right? Perchance and Glory. If you experience it now, when you like a particular movie, or you see a particular movie in YouTube, the next one do not recommend one for you, and that will be so interesting. You so love it.
Also, when you update maybe you are the schools where you went, they always bring your classmate or people who are in that school, something like that.
Exactly. That's good. That's a very good one. That's true. You see, people you know, and indeed you know them. You wish to connect to them. Even at the time, the one period on Facebook that they recommend my long-term friend in secondary school, I was not asking how did they these guys here. So that's to say they use my profile. Let me speak. So they use my profile. They recommended various students for me.
Nowadays, even organization, for example, you want to apply to a certain job on LinkedIn. I found that you'll find, for example, if you're applying for Microsoft and they have advertised, they'll tell you one school alumni, what's here. I don't know if someone else has noticed that they are doing that.
But I've not noticed. I've not noticed it, Sha.
Or when you be careful, because you can take any organization, you always find that if you have updated your schools in those social media, you'll find that one school alumni what's here, but they don't say who. But Facebook and then
it's true.
But for the Facebook and the others, they bring the specific. But for LinkedIn, I've realized they just tell you one school alumni or 6 alumni is working in this organization.
Yes. That's just it. That's basically it. All right. So now on in our day-to-day activities, can you think of the problem you face daily and think of how data science can be used to solve that problem? your day-to-day activities. For example, now I'm going somewhere. Now, I want to use it for my own self now. I like going to Oshobo, or yes, I like going to Oshobo, yes. And I always experience traffic. And I like to go to Oshobo when I don't have uh, at a minimal traffic issue. Now, I would like to build a model that will help me, that will suggest my likely route. That's what we are saying here. That's my day-to-day activities. Now, so to you now, what do you think in your day-to-day activities that you can apply data science in to solve a problem, your own personal activities day-to-day? Not a synthetic one, your own personal activity, day-to-day tasks. What tasks do you think that you think that having this skill will help me to solve this thing for my own personal good? Charlie? Apachas?
Yes, I'm with you.
Now, we are bringing it down to yourself now, to your personal, your own person. What personal problem you think that you can use data science to solve? We're not generalize it to now your own personal problem you've encountered in recent time or always. I think you can apply data science to solve it.
Sincerely, I can't think of any personal problem that data science can solve now. Yeah, I just have to be candid. Sincerely, I can't think of now because can data science can machine learning be programmed to generate finances for me now? That's my biggest daily challenge, finances.
Hey,
but it can give you ideas on how to make money.
Ideas. I can ask ChatGPT or Google that now.
That's it now. They use it there now. They use it there now. Data science is being used.
Just Google that.
It's used in ChatGPT. ChatGPT, Google, they all use machine learning to get their insights or get their predictions. These are what ChatGPT we use. With machine learning, they use their large language models. They use different agents at work. Yes. Different agents at work. Yes, that's it. Okori, can anyone from your end, if Mr. Charles on is to get money for him? Everybody for you. Mr. Okori knows
I'm challenging Charles because I have tried that. You can give it an idea, like this is what I want. What can I do with this? What dots line can I, even if it's a business model, it helps by the way.
Okay.
For me, I think I can use it. What can I use to predict? I think I can use it to automate tasks. I don't think I have repetitive something like that.
I don't know if anybody has practiced this. Your personal finances, analyze your personal finance in a month, then predict your likely expenditure for expenses for next month. You can use it your own personal self. One thing that we analyze will not analyze our own data, talk more of company data. Learn how to analyze your own data first. Use your own data to solve your own problem. How you getting me now? Before you now pull it out. You can build a model that will analyze that will predict your expenses or your expense or budget for next month. At least it will help in your spending. If I spend like this, these 2 months, this next month, what I will spend will be like this. It's not help you. You not be cutting your expenses. It helps though. All right, Mr. Corey Moses, anyone from your end before we proceed to the next?
Okay. I think that with data science or data science, to me, I can use it to like plans to create a model of my daily activities, which I may likely always do in futures. So, and also the people I came in contact with and how I interact with people. So I can use models to know what I need to amend in future and what I need to adjust in future.
That's your own personal life, but all right,
Yeah.
that's good. That's good. That's good. That's good. Yeah, the next one is a data science workflow. We've explained the key. We've explained the key concepts. The workflow is a process that guides data scientists through solving their real world problems using data. That's a workflow. I think I've explained those workflow. They are under the key concepts. But what are we doing in various phases? Number one is problem definition. What happens here? What is involved here? Here you clearly identify your problem. That is what is the goal of this project? What is the who will use the results? So all these things happens. What is the outcome? Because a data scientist have various approaches in solving a problem using data. But in this problem definition, that is where you have to understand what my business owner, what does he want? What does it want? There are key questions that you ask. You have to ask those key questions. Very important. What is the goal of this project? Our goal is it to predict or to classify? Am I building a classification model or am I building a education model? Because we have different type of models. We have classification model and we have regression model. This project is it a classification model or regression model? If I'm predicting a rate of malaria severity, that one is a regression problem. If I'm predicting if a patient will have to come back or not, that one is called classification problem. You must define the goal of the project. What specific problem are we trying to solve? Who will use the results? And what is the expected outcome? All these are questions that should be asked in a problem definition. Because that will tell how you collect your data, how you clean it, what measures will you add when cleaning your data. And secondly, data. This involves you data collection. It involves you collecting data from various sources. A data scientists collect data from various sources using API, web scraping, survey, even from softwares too. That's software API. I've said it that APIs. A data scientist has a very big task when it comes to data collection. You write a code that automates scraping, a code that automates taking from APIs, bringing out a survey form. So these are kind of ways in which a data scientist collect data. Because like data analysts, you might not go into that in depth to using API or web scraping. Your own work is just to Your own work is just to analyze, even though to collect self is still your duty too. But collecting data from API, from web scraping, those ones are the core tasks of a data scientist. All right, because we use softwares for that. We use code programming language for that. You write codes for those ones. All right, then the next one is cleaning. You know, cleaning involves still the same step in a data analysis process where you clean, you remove NaN, you ask your stakeholders about the missing values there, if it will be removed or replaced. And also standardizing of our data features. Yes, this is very, very important because our machine learning models, they perform well when our data is, when the particular column is standardized. How? Can we explain that? You know what is standardization, Abi? You know what is standardizing of data columns? You know what it means?
Not really. I no, sir, I don't.
Okay. Who knows?
Yeah. Standardization,
Right.
I guess
Explain.
it revolves around normalizing the distribution, so you don't have
Exactly.
extremes.
Fine. Thank you. That's it. You know, machine learning models works perfectly well when your data are normalized, when they are standardized. Yes, it easily predicts easily. So this is a process where you process our data and also standardize them. And analysts will not do this because it's only just what insights, but you will do it. So the activities that a data scientist does in a particular phase and analyst, they differs. I guess they differs. We don't clean, we don't drop some things, some columns anyhow. Why? Because we want our model to be accurate. We don't drop anyhow columns, even if they have missing values. We must find a way to treat them and use them in our model. Because that particular case I told us about ALC tests, we have 4 different categories. We have less than 7, less than 8, greater than 10. We have something present. Then the other one is missing value. So the idea now is to categorize those four cardinals into categorical variables and code them into numbers. Sorry, they are categorical variable already. Just encode them into numbers. So the idea is that particular missing value now should be a different category because that column itself is useful for our model. So that's one key area that we need to we focus in data cleaning. Then after that, we now perform our analysis. That's the EDA. Yeah. You explore the data. He said, we explore the data, clean data to identify patterns, trends, and relationships. We mostly call this EDA. That is to say exploratory data analysis. We explore the clean data. We perform some statistical summary, the main, the median, the mode, and then get our distribution to get insight. Also do a correlation there too. All these things are being done for because if you don't visualize well and understand patterns in your futures, you won't really know how to engineer data. What we call data engineering, future engineering. You engineer feature to create more feature that will help your model. To create more feature that will help your model, you engineer. And before doing engineering, you must understand your features. And we do that in EDA, the analysis process. We analyze various features, pair them. We do multivariate and univariate, multivariate and bivariate analysis. Analyze your features them together to understand patterns, if they can be engineered to create more features or not. when you get to data science, you understand what I'm trying to say. And then that's that for analysis. The modeling, yes, you build your models, you test. Now, in modeling, this is an iterative process in the sense that you train a model, you go back, you have to engineer. After engineering, you come back, you train, you test. You are experimenting with different algorithms. If it's a regression problem, you engineer using the linear regression model, logistic regression model, ridge regression, and the support vector regression. All these are regression models that you want to experiment on. Then after that, you now make your final conclusion after evaluating your model. That model evaluation, that's the last. After modeling, the last one is a evaluation. Then after that, you will not deploy. Model evaluation before model deployments. I didn't add it here. Ought to be here. Model evaluation. So if it's a classification problem, you have different classification algorithm. You have decision tree, we have random forest, and we have SG boost, we have light GM boost, we have other one, we have decision tree too. Logistic also can also help you for classification model. We also have other boosts. All these ones are different types of. We have Lasso classifier. They're all different types of classification model. Any question, guys?
From my own end, no, for now.
So in short, deployment means making the data available for end users.
Yes. Okay. Now deployment is kind of yes, making it available for end users. Push it there either locally or online. Like recently now, you can deploy model using Streamlit, using Flask server, Streamlit server, Flask server, or even AWS or even Google Cloud. There are many servers that you can deploy a model in. After building your model, writing those codes behind, how can we use the model? It should be what's deployed for users, for end users to be able to interact with your model. That's why you build your GUI. You build your GUI, the interface where users will input their figures, input the age. If it's to predict the house price of a real estate company, example now, a real estate company want to know what the cost that they will sell their different houses. Now, I want to build a model that will help them to predict the price of a house. Of course, they have the length, the sizes of their house, the number of bedroom, number of kitchen, location, all those features now. So you design the GUI for it with those interactive either drop down box or selection box. You will now design then the model will now predict behind. I've deployed few models, at least I've done that. So all these ones, those particular workflow, you get more understanding in data science proper. I believe you also follow us to the ending. This is data Python basics. We have advanced and we have data science. So I believe you get there. You get there. So any question, guys? Ask a question. I think that's where we'll stop for today. Okay, we can still touch. We can still touch some other things again. All right. Any question, guys? Let me.
Okay, I don't understand the standardization Glory talked about. Then I don't know. Maybe you could explain better.
Okay. For instance, now you have data sets, a particular numeric column like age, and we have age like 5, 6, 7, and we have more between we have few like 5, 6, and 7. and we have more between 30, 40, and 50, and 55, and we now have 1 or 2 or 3 at 80 or 90. Now we have data at the extreme. Are you getting me now? Now, what this thing does is that it helps you normalize the data and to bring it into, make it to be in a particular region from 0 to 1. Like in cleaning process, we have cleaning process. We also have data processing also in it. So they are functions that help you to do that. We have the standard scaler, we have the robust scaler, we have the normal scaler, normalizer, and there are 4. What's the other one again? Okay, I think I've called 4 just now. Standard scaler, normal scaler, normalizer, min-max scaler. These 4 scalars, they help you to standardize your data points. I think bring them closer, either from -1 to 1 or 0 to 1. It will normalize it. Are you clear now?
Yes, better.
Maybe I can.
Okay.
I can give you an example. Oh, sorry.
Go on. Give him an example.
I wanted to use an example that doesn't have figures before we go to the figures. So
okay.
Let's assume in this class or in just a normal class, even in elementary level, Mr. Charles, every teacher, their work is to ensure they don't have extremes because they are fast learners, they are slow learners, and they are mid-row people, average. So the teacher will try to standardize the data so that it doesn't have maybe a lot of D's and extreme A's. You understand that? I don't know if your national exams, they do that. Now that is during exams, but I'm giving you a layman example. Every teacher doesn't want to have those extremes. Like you don't want to have many students below average, like having D's and D's. So you try to push maybe that through teamwork, making sure those who are fast learners are helping others so that it can have a normal curve. It doesn't have a lot of extremes towards low grades, and also trying to standardize those who have A's. It's called a normal curve. So you don't have a lot of outliers, like data that is outside, like the way that Mr. Promise is trying to explain. That's just a layman without involving numbers. Now, when it comes to numbers in the national exams, they also do that. But at times, of course, Africa, they take advantage and promote some schools. I don't know if it happens in your country, but in my country, like now the results were released, they try to normalize the curve so that we don't have extreme, a lot of students have been knocked out of from the universities. So they try to make it an average so that we don't have extremes in both ends. So that is what is called standardization. Now that's a layman without involving numbers and just in a layman's language.
Very well. At least she has nailed it for you.
I think I get the perspective, but is that not an unnecessary data manipulation? Because the data wouldn't at this point paint the if you are avoiding outliers from your data at this point, the data wouldn't give a good picture of what is, so to say, happening. Or it means you are actively seeking to remove data, is it not?
Okay, let me come in here. That
is what it means, because you are actively seeking to remove outliers. So if you are removing those outliers, which means the analysis you are doing wouldn't be giving an ideal picture or as it should be.
Okay, let me come in now. Let me come in here now. I'm not analyzing. Are you getting me now? I'm preprocessing my data for modeling. Are you getting me now? I am preprocessing my model. Mathematically, data science is application of computer statistics and programming language and terminology to solve with data to solve problem, right? Now, that particular step is valid statistically. Are you getting me? It's valid statistically. You have a formula. how to normalize your data. Is mathematical is correct. I think the mean minus, the value all over divided by the, I've forgotten the formula, but statistically it is correct. Is not wrong.
Yeah, it's not something, Charles. It's not manipulating data. That's something statistical. It's called a normal curve. Because if you have outliers, your curve will not be normal. It's called a skewed curve. Maybe it's skewed towards the left or the right.
I understand I think I understand what you mean by a normal curve. You understand it has a normal distribution. But what I'm saying is, in an ideal situation or in a real life situation, let's say we are just discussing now anyway. Let's say you have 50 students in a class. Ideally, as a teacher, you expect the bulk of your students to be within the normal distribution. Give or take, there will be students who will be outside the normal distribution. Maybe a class of 50, you might have what's it called? 5 students on this extreme and 5 students on this other extreme. You get so now maybe you are now having 40 students on the normal distribution, while 5 on the extreme. So the standardization you're talking in this sense now, at this point, excludes my understanding of what you're saying, excludes these 10 students that are on this extreme. Now, maybe the very exceptional students and maybe the very dull students.
It doesn't exclude. No, you're getting it wrong. Those 5 are part of the normal. You are trying to make sure that we don't have like 30 students at the extreme left or 20. So in your case, that's already a normal. You have 5, 5. So the equation is balanced at the average.
See, what we are trying to do here is that,
you are not eliminating them.
No. You're not eliminating, you are normalizing them. That's working with the average, bringing them close. That particular method helps. It helps your model in prediction. But if they are extreme, it is either skewed to the left or the right. Machine learning model perform better when their data points are normalized. When they are normal curve now, it's not here. But if it is left skewed or right skewed, it's not really, it really affects the model in predictions. For predictions, are you getting what I'm saying?
Yes,
it's not a wrong or an invalid way of reprocessing. It's valid. Statistically, it is valid. It is valid. Of course, when analyzing your data, analyze that numbers are also place. But now, I am now normalizing my data. I've done my analysis. I've done everything concerning analysis. I've gotten my insight. Now I want to model. Now it is good for me to now normalize my data, process it for my model. This particular method will help my model to perform better, to be at its best. Cleared?
Okay, sir.
Are you getting me now? I didn't delete the student too. I didn't delete it. I just applied statistical formula and brought them together. They are close. No worry. The formula, if you make a research more about that, you will see that it helps to normalize your data for
another thing. Oh, sorry.
Okay, go on.
I don't know if you people in Nigeria have national exams, because that happens in a lot in my country until it brings politics. Like whatever is marked on the ground, it's not what will be represented in the country. And not that they will cook the results, Charles. Okay, at times in a normal setting, like in a fair ground, they don't cook result. What they can do is like they try to make the grains be broad. They can say even an ace from maybe 100 to like 70, whereas in a normal setting an is from 100 to like 84 points. But in this one, you'll find like they have stretch rate. They can also say maybe a D minus is from this to this, to avoid that. The real result will be there, but when it comes to the presentation, it will be different. Not that they will manipulate the results. They will just try to stretch the ranks. I don't know
All
if
right.
you're in your country you have that, because for us in the last last week the results were released and they have brought a lot of commotions. That of course Africans, not there's corruption and everything, but as Mr. Promise is saying, it's a normal way, but some take advantage of that, as you say.
Yeah, there's always a rule in taking any step, a reason why you do certain things. Don't just normalize any data anyhow, it will affect the model. But there are reasons when we do that. At times you want outliers, extremes values, and you don't want to kick them out. You now what? Normalize them to still leave them on data set, because working with real life data set, you don't remove data point anyhow. This is the outliers. Recently, there's one work this we did for one real estate. I think that was real estate company. Their houses kind of in certain regions, their salary the salary of those customers was high, so they not came as outliers in the data set. Imagine where average earners are within will I say within how many years the last within 350 or so. Someone is earning more than $800, just 2 or 3 persons in that regions. Those 3 values are outliers, but we don't want to kick them out because they are real number. What we did there is to normalize it so that you not fall between 0 and 1. It's not a sin. It's a good practice. But you don't just normalize anyhow values, normalize them. At times, it will have an effect on your model. That's just it. That there are rules in anything we do here. There are reasons and rules why we do them. State it and then go on. Do and go on. All right. So before we leave, I think we can take that. Now, what is data? So far we explained data analysis. This is what is data? What is data? Before we close, I think we'll end here. Then Wednesday we continue. What is data? Go on, and with you, Glory or Papa Charles.
Data is a collection of values, and the values could be numbers. It could be pictures. It could be voice note. It's just a collection of values. That's what data is. It's just
All
a
right.
collection of values.
Yeah. How about big data? What is big data?
Big data.
Yes.
Big data is a lot of data, plenty of data that cannot be analyzed easily. It's just bulky data, a whole lot of data. That's just what big data is. Big
I think
data
they are okay, go on.
for instance, an example of big data, the data of all the bank customers in Nigeria. So if you are looking at 90 million bank customers, that is a whole lot of data in Nigeria across board. So I think that's an example of big data.
Okay. Can you help us out? Lori, what is big data?
Me, I don't know just the other one, big data. But for me, I guess data, I will not describe it as value. I will say it's information, because values it's more of discrete numbers and not text and that. So for me, I would think data is information that could be, as they have described, pictures, text, in a form.
Data are raw facts. Our primary definition. They are raw facts and figures collected for analysis. It can be text, it can be images, it can be messages, it can be voice notes, etc., etc. Now, big data is there is a lot of data. There are features that characterize big data. Yes, there are features. One, volume. I think there are 4 V's or 3 V's of big data or 6 V's of big data. Just note now there are 6 V's or 5 V's. 1, volume. 2, veracity. 3, velocity. Yes. Then 4. Although it's not in this curriculum, it's not in this our course content too. I just asked the question. Big data is voluminous, and big data is veracity. When we talk about veracity, is varieties. It can come on different form. There are varieties, different form. Those are the characteristics of big data. So if the data is not in different form, if it does not include picture, does not include sound, does not include numbers, I don't think it's called big data. If it's not voluminous. I get me, Mr. Charles.
Yes, I'm with you, sir.
Yes, so it's that the V's of big data. We talk about it's 5 V's actually. We talk about the volume, volume.
Velocity.
That's it amount, vast amount of data from various sorts. That volume. Then velocity. That's the speed at which the data is being generated and processed. Then the varieties of data. That's to say it comes in different formats. That's the 3 V. That's 3 now. The V now is 3. It comes in different formats, different structure, and different sources. Then we have veracity. That's to say it talks about its accuracy, talk about its quality and reliability of the data. That's the veracity. Then we also have another one. It's called value. Yes, it's 5V. Yes, I know that it's 5V. Value. The value, how useful and how relevant is that data. So I think all these are features that makes up your big data. If a data does not have these 5 features, I don't think it's a big data. All right. Okay, I think we are good to go. Any question, guys? So we can call it tonight and continue on Wednesday, on Friday, sorry. Today's Wednesday.
On my side, no.
Mr. Charles, any question?
No, sir, for now, no.
Okay, I believe we are all ready with our tutorial notebook and the VS Code and PyCharm.
Yeah, I downloaded mine today. I downloaded the VS Code and installed, downloaded the PyCharm, and also downloaded the Anaconda, and there was one last Jupyter notebook. I think I did something on that also today. I don't know. So that's just basically that for me.
Okay, that's fast. All right, Mr. Corey. All right, now we say you just came to observe us now. All right, you're welcome. All right, everyone. I believe next class we'll start using our Jupyter notebook in our next class while we complete this other point here. All right, have a lovely night rest. See you guys on Friday, same time. Stay tuned and be very, very ready for the class. Thank you and have a wonderful night's rest. Bye.
And you too, have a wonderful night rest. Thank you very much for the stimulation.
All right. All right.
Kawira wo.